The first one is going to be a moving sum of the present values. The other one is going to be a moving sum of the cross products. So let's get started. I value as the present value of the face, and I sum remember that balloon payment is going to come in this example 84 months from now. So I multiplied present value of that with 84, or number of periods. In this case, well, let's do another one. Let's call this J value. That's the present value of periodic payment on that period. So I'm going to add that to I value. So that becomes a moving sum of the PVs. And to the I sum, I'm going to add J value times I count. So when you're done with this loop, I value contains the numerator and denominator, and I sum contains the numerator. Hence, bond duration, this is technically Macaulay duration now, is I sum over I value. And bond duration, Macaulay duration divided by 1 plus rate. That's the period rate. Since we're doing everything in periodic numbers. We should be home. So let's calculate that. Again, the same deal. Pick your function, bond duration. I rate is the periodic rate. I coupon is coupon amount. I pair is number of periods. And I face is the face value. This number doesn't have a dollar figure. This is basically the number of periods. So in this case, the average number of periods, right? So if I divide that by frequency, that's going to tell me that bond duration is about 6 years. Or alternatively, I'm going to actually multiply this whole thing by I'm going to write a little note here. This says bond duration here means percentage change in the value of the bond approximately for 1 basis points change in the interest rate, the APR. Since if interest rates increase, bond value is going to decrease, so I'm going to put a negative in front. So if interest rate goes from 4 to 4.01, then value of this bond is going to decline by about 0.06%. Okay, that's the interpretation of bond duration. Actually, let me have this different color. Again, it's just a matter of scale. I like thinking about 1 basis points moves because they're kind of what we see. And this is approximate. Theoretically speaking, the bond duration that we calculate is for a very small interest rate change. And if we want to see whether we've done it right, let's go to the file we had last time. Not info, open. Here we had, we've done it kind of the old-fashioned way, yield to maturity. That's pretty much the same number. And I'm going to actually copy the format of this and put it here. Very special. Just the formatting. Oh, since I'm doing it as BPS, this is going to be let me actually make this. Okay. I'm already expressing it as number of basis points. That's pretty much good enough for me. So approximately speaking, so if this was a 30-year bond with semi-annual coupons, I don't know who the hell these guys are. If this was a 30-year bond with semi-annual coupons, for each basis points move in the interest rate, value of the bond would have gone down by about 16.5 basis points, or 0.16%. And this is not going to be any different. just want to have the notes over there. Where are you?